Hello there and welcome to Lower 6th Further Maths A-Level. This is the practice paper working on questions from June 2011 for the pure part of the syllabus. Here we're on question 10. The plane P has this equation. Find a vector perpendicular to the plane P. And that makes sense because each plane has two different ways of writing the equation for it. The first way is this way, where you have a starting position on your plane and then two direction vectors that travel along the plane that are non-parallel. And the second way of writing a plane is to use the perpendicular vector to the plane. And as the angle, or as the direction of this n vector changes, obviously the direction of the plane will change, and therefore it uniquely defines it. So how do we find this n vector from this plane here? Well, what we do is we create three equations, x, y, and z, that correspond to the cells inside these vectors. So obviously the x equation will be formed with these three values, multiplying the 0 by lambda and the 3 by mu, which we'll go ahead and do to start with. So we'll get 3 plus 0 lambda plus 3 mu. And for the next part, we'll get y equals, using the middle cells on each of these vectors, 1 plus 2 lambda plus 2 mu. And for the third part, what we'll do here is we'll get the bottom cells for each of these vectors, so 2 minus lambda plus 2 mu. Okay, and what we need to do now with these three equations here is we need to rearrange them in such a way that the lambda and the mu will cancel out of both of these equations here. So what I think I'll do to start with is I will rearrange this one here and this one here so that I make, first of all I think I'll do the bottom one here. There's lots of ways of doing this. I'll make lambda the subject. So lambda equals 2 take away z, add on 2 mu. And with this one up here, I'll make mu the subject. So mu equals x minus 3 over 3. And what I'll now do is I'll substitute in lambda into the y equation, but wherever mu appears, I'll substitute mu with this x minus 3. So let's get going. Y equals 1 plus 2 lots of 2 minus z plus 2 mu, but mu is x minus 3 over 3, so it's going to be plus 2 lots of x minus 3 over 3. So that's the first part, 2 lambda here, and then we need to do plus 2 lots of mu again, so that's x minus 3 over 3. Okay, the next thing I'll do, I don't like these fractions, let's multiply through by 3 on each of these values. So we're going to get 3 plus, we'll leave the 2 out the front, we'll expand the brackets at the same time I think, so we're going to get 4 times the 3 will get 12, 2 times the z times the 3 will get minus 6z, and then because this is all a fraction over 3, none of this needs to be times by the 3 part, but it does by the 2 and the 2, so this will be plus 4x and minus 6 minus 12. And then for this part here, we've times by the 3 already to cancel out this divisor of 3, so it's just going to be 2x minus 6. Okay, so what we'll do now is we'll simplify all of the, well, this 12 will cancel out with that 12, so we'll put the numbers on the left, so that will be 3 on the left, and we'll bring all the letters onto the right, so we're going to have 6x minus 3y minus 6z, well, we can cancel through by 3, so we'll get 1 equals 2x minus y minus 2z, which is the equation of the vector in Cartesian form now. So we can jump straight to writing it in r dot n form. 2 minus 1 minus 2 equals 1. So therefore, the answer to part A, the perpendicular vector n, is 2 minus 1 minus 2. Okay, perfect. Part B, I think we'll squeeze it onto this page here. We have a point A, so A is a point up here, and the point P that they intersect at is this coordinate here. The acute angle between the plane P and the line L is alpha. So this angle here is going to be alpha. Find alpha to the nearest degree. So first of all, what we need to do is we need to work out the coordinate from A to P. And the classic way of doing this is by doing coordinate P, take away coordinate A. So take away 1, 3, 3. And what we get here is 2 minus 2 minus 1. Okay, so now we know that vector. What we're going to do to answer this question here is first, before working out alpha, we're going to work out this theta angle here. That is the angle between our perpendicular vector and our vector A to P. So what we'll do now is A to P dot with n, and use that scalar product rule. That's going to be A to P dot with n vector times by cos theta. So using this formula to work out the angle between two vectors, we're going to have 2 minus 2, 1, so 2 minus 2 minus 1, dotted with the n vector, which is 2 minus 1 minus 2. And this is going to equal the modulus of the AP vector, so that would be 2 squared add 2 squared add 1 squared, times by the magnitude of the n vector, 2 squared plus 1 squared plus 2 squared, times by cos theta. So working all of these values out, 4 take away 2, so 4 add 2 because it's double negative there, add another 2, you get an 8. And we're going to divide through by these moduluses. Now this is going to be 4 add 1, that's 9, so square root of 9 is 3. And then it's going to be the square root of another 9, which will give me 3 as well. So that's going to be 3 times 3 is 9. So cos of cos minus 1, or to calculate the angle, we're going to do cos minus 1 of 8 over 9, which gives us 27 degrees. Now this is going to give us our angle theta up here, so to work out the acute angle between alpha, so that it is alpha, we need to then just do a 90 minus 27, and we get the final answer here, which is 63. So that's our final answer for part B, 63 degrees. And the way we've done that is we worked out the angle between AP and N, and then did 90 minus it. Okay, the next part is calculate the distance from A to the plane P. And here, all we need to do is recall that formula that we've learnt in lessons n1 times alpha, n2 times beta, n3 times gamma. So this is the coordinate that is effectively in the formula here, alpha, beta, and gamma. And then we have to take away the d part of the equation of the plane. Remember, the equation of the plane we found was, r dot 2, hold on, let's recall it here, 2 minus 1 minus 2 equals 1. So that d value here is minus 1, and we got n1, n2, and n3 here. And then we divide that by the modulus of the n vector. Okay, so plugging this all into the formula, and we're going to get 2 from this 2 on the n vector here times 1. And then we're going to get minus 1 times 3, and then we can get another minus 2 times 3, and then we have to take away d, which is this value here, that's a 1, and then we divide through by the modulus of the n vector. That was the square root of 9, remember we found that out earlier. So this is going to be 2, take away 3, that's minus 1, take away another 6, that's minus 7, that's minus 8, so that's going to be 8 once we've modulused it over 3. So that's the answer there, square root of 9 was 3. So 8 over 3, or 2 and 2/3, is the distance from A to P. Great, that's 10 marks in total for that question.